hang up and try again.
We will continue with the case study of dollar. We will discuss inheritance and method overriding. These are two attributes that we got as an object orientation programming paradigm attributes, which means that only object-oriented programming owns this ability to perform inheritance and method overriding. Java turns out to be one of those object-oriented programming languages. Today we're going to discuss as a case study a Canadian dollar, just an extension of dollar by using inheritance. If you remember, we discussed in the previous session the attributes for an American dollar. Similar as you can see right here, we discuss a couple of attributes and characteristics, what makes a dollar unique. In other words, the fields. After that, we create constructors, which are important to initialize all those fields, and we provide a couple of customized constructors as well. Finally, we implement methods that corresponds to getters, setters, that provides the ability to retrieve and modify the fields from an object. Additionally, we provide other methods that helps to perform certain operations functionality inside of the class dollar. The Canadian dollar has something similar as the regular American dollar we have. As you can see here, we have a couple of variety of Canadian dollars, very similar to the ones that we have in American dollar. There is one main feature here that is highlighted, which is the color. So every Canadian dollar, they have also denomination, as you can see here. They have a couple, 5, 10, 20, 50, and 100. They also have a face corresponding to that denomination. Additionally, they have some serial number, but not only that, they also provide a barcode. As you can see here, there's a barcode with the serial number representing that part of the dollar. And they have a year, similar as the dollar one. Additionally to those four fields or attributes, we also have the color. As you can see, they have for the number 5, some kind of bluish, 10, some kind of purplish, 20 is a green, 50 is a red maroon, and 100 is yellow gold. That gives this dollar a more unique attributes for all of those Canadian dollars. In object-oriented, we have this relation called is a. It's called inheritance. The way we extract information, we inherit attributes, as we already discussed previously, is by providing a keyword called extends. The word extends allows you to inherit. And inheritance in computer programming is very similar as the one that you probably have been thinking in real life. When you inherit something for your ancestors, you basically get it for free as soon as you get initialized. Wealth, health, last names, physical attributes, diseases, all of those kinds represents inheritance. And in object orientation programming, we provide similar mechanisms to provide inheritance to future generations. These future generations allows us to basically reuse a lot of the attributes that we already have in the superclass. Here, dollar is considered to be a superclass because that's the main ancestor. Canadian dollar is what's considered to be the subclass. The relationship between a superclass and a subclass is by denoting this arrow. The arrow goes from bottom up, specifying the superclass to be on top and the subclass to be in the bottom. Now that we have this diagram, let's pay attention what we need from the Canadian dollar. In the Canadian dollar, we have a couple of new items that we need to incorporate. Of course, Canadian dollar will have the same fields as dollar, like denomination, face, serial number, and year. But in addition, they will have color. This is what makes Canadian dollar so unique. The constructors, probably we can use the same ones from our superclass, but we want to create one customized constructor that takes the 4 fields we want in addition to a string as the last part to represent the color. Methods, we need their getters and the setters, And in this particular case, we're gonna override the toString. Let's take a look in the code. As you probably remember, last time we create the dollar, here are the fields with the proper encapsulation data type. We also have the constructors, in this case, the default constructor that provides a default values to all the fields. Customized constructor number one, it provides 4 parameters to the 4 fields, and the customized constructor number two that provides 3 parameters for the fields, having the other one just let it to initialize based on the denomination. The name of the constructor should be dollar, the same name of the class. They don't have a return type. Doesn't mean that they have to be void. They just know return type. That is an indicator you're talking about a constructor. And they should be public in order to allow them to generate everything in the object dollar. Additionally, we have the getters. Start with public, give a return type that starts with the word get, followed by the field you want to extract. They don't take any parameters at all, but they do return the current field that you're requesting. Setters, on the other hand, they also start with public, but they don't have a return type. They have void. They start with the word set, followed by the name of the field you want to extract. They do take parameters this time because that will represent the new value for the field you want to change. And finally, we have other methods in order to perform certain functionalities. We have printinfo, getAge, and we discussed toString very briefly last time. The toString will take an important role in this session when we define the class Canadian dollar. Notice that the Department of Treasury is a separate class that is saved in the same working directory as dollar. And here's when we create the instances of dollar. Here we illustrate the 3 types of constructors: the default, customized constructor number one, customized constructor number two, and how we use the toString by using system.println and then the name of the instance. So let's go ahead and create Canadian dollar. Once you create Canadian dollar, also in the same working directory where the other objects are created, since we want to achieve this relationship that Canadian dollar is a dollar, we need to incorporate what we call extends. Extends, ladies and gentlemen, is a keyword that allows us to extract all the information from our ancestor. We indeed need to provide which object we're planning to extract that information. This is a contract, ladies and gentlemen. The contract says the following: Canadian dollar is a child of the object dollar. Dollar is our superclass. We are the subclass. Automatically, once you incorporate the word extends there, all the attributes from dollar will be inherited to Canadian dollar. Notice that the fields on dollar, they're private, so you cannot inherit them per se, but you can use them through setters and through getters. Constructors, you cannot inherit it. However, you can use them by using the keyword super. I will show you in a little bit. The first thing is to define the fields of this Canadian dollar. Notice that we only have color as the field for Canadian dollar. The rest, we will inherit them. We can use the constructors, the next thing. Notice that I'm using the default constructor. Remember that the purpose of the constructor is to initialize all the fields. So if that's the case, I'm gonna call my superclass. And notice that here is providing us automatically the constructors that we can use. Here we can use the default constructor from the superclass dollar, or we can use our superclass first customized constructor or second customized constructor. We're interested in the default constructor for our superclass, so we can call it this way. But remember, we still need to initialize this color. and we will initialize it as a null. We can provide a customized constructor, which is a constructor that provides all the fields that we require in order to initialize all our fields. And it looks like this. Here I'm providing the 5 fields required to initialize a Canadian dollar: denomination, face, serial year, but also color. You might think, Professor, we don't have any of those fields in this class except color, but we will call the super constructor by using the following line of code. In this line, it will tell Java, hey, call the superclass dollar and send the following 4 parameters that I'm providing to you. Java is smart enough to go to dollar, the superclass, and visualize the following. I'm looking for a dollar int string string int, and it will start looking for it here. Here, I found you. False. You only have the open close. You probably need to look for somewhere else. Okay. Here, I found you. True. This is the one that you're looking for. It takes an int, a string, and an int. So this is the one you're looking for. So the message provided by the Canadian dollars, it will tell you here, I have 4 parameters that will be used to initialize the following 4 fields. And indeed, this is how you're going to initialize it. So this line that you can see on line 12, it basically invokes, it calls the super constructor from the class dollar with the following 4 parameters. We still need to initialize this color, but that's no problem. We can just say this color will give the color from the parameter color. We are required to provide getters and setters. So we will provide our getter that will return the following color. Setter will set a new value for color. Those are the 2 methods that is required in addition to the toString. I'm gonna wait a little bit about the toString until we demonstrate the following usage of Canadian dollar. In the main, I will create a new instance of Canadian dollar. As a matter of fact, I will create 2 instances. The default constructor will only just print the default values from a regular Canadian dollar. Basically, the default values for all the data types. However, Canadian dollar C2, I provide a couple of information. Provide the denomination 20, and then the phase will be Queen Elizabeth II. The serial number, I just generate a random serial number. The year, and we notice that is green, the Canadian dollar, representing for the 20s. I don't really know this. I just found it in Wikipedia. When I go to Wikipedia, I notice that there is some specimen here for the series of Canadian dollars. We also notice that the Canadian dollars is determined by the C and then the dollar sign. Notice that the Canadian $20 note, there's some information here that give us this description. The sign comes with Queen Elizabeth II and other items that are probably irrelevant for the purpose of this design. I just want to show you where I got this information. Having created this part, let us print the values of Canadian dollars. Let's save, compile, and run this program. As you can see here, there's a lot of information because we've been printing the regular dollars. But if you pay attention the last 2 lines, here we're trying to print the default constructor for Canadian dollar and the customized constructor that we got, which is indeed what we were expecting. The nice thing about this is that we didn't have to use any of the other methods or fields provided by the regular dollar. Here instead, we inherited from it. Notice that there is some regular way to express a dollar, But if you are actually reading this information, you cannot really distinguish between a regular dollar and a Canadian dollar. I mean, unless you really know who belongs to what. But in reality, it looks pretty much the same, the textual representation. We probably want to see something more unique. We want to see something more unique from the class dollar, the one that we inherited. That is why we're going to overwrite the toString method in the class Canadian dollar. I'm going to leave this part here so you can see the contrast in a little bit. In the Canadian dollar, we thought that maybe we want to represent our uniqueness by providing the color and maybe that C that we saw in the Wikipedia page. So we decide to overwrite our method toString. The method toString, ladies and gentlemen, is one of the unique methods that we inherit from our ancestors in the class object. The class object is the great ancestor for all objects in Java. It contains 11 methods that we actually got for free every time we create a new class in Java. Now, the class dollar, we kind of overrode one of them, which is the toString. And we're going to do the same thing here by overriding the toString from our superclass dollar. We don't need to get rid of everything. We can keep a couple of those items. So that's why we're going to use the power of inheritance as follows. We still need the toString from our ancestors, but we would like to incorporate a C just before the dollar sign to denote that we're talking about the Canadian dollar. And at the end, probably we want to concatenate, I don't know, something like color, C for color. I know C is for cookie, but C is for color. Here we can put get color. This will create a more unique representation of the class dollar. Let's go back to our terminal. I'm going to save this program, compile, and leave what we left last time there. I'm just going to compile the Canadian dollar that comes from the Department of Treasury and run it again so you can see the contrast. Notice that the toString in the last two lines, now you have the C on front of the dollar sign. And also towards the end, you have the color green. Notice that I did not touch the Department of Treasury. If we go back to our code, the Department of Treasury was intact. I didn't touch anything, but Java is smart enough to kind of modify that automatically because everything gets interchanged dynamically every time you compile this program, Department of Treasury. We can prevent that inheritance if you want to. We're talking about a contract. Let's go back to dollar. In the contract of dollar, notice that you have all these fields. But if you notice that eventually someone wants to modify the way you represent some of your methods, like for example, the toString, you can prevent that. The way you do this is by after the public, you can put a modifier called final. The final, we used to work with this one. Every time you want to define something in a class and no one should be touching that thing or modify them. There's a couple of examples in our classes that are final, like the value for pi or Eulers. Notice that they're considered to be final. And in similar fashion, you can do the same thing here. By creating final, if you go to Canadian dollar, notice that you still inherit everything from dollar, but there's going to be a problem when you define the toStrings. Notice that toString already identified there's something funky here. It's not explained, but when you compile Canadian dollar and Department of Treasury, again, let's go back to our console. When you attempt to compile Department of Treasury, expect a problem. The problem is the following. Error. toString in Canadian dollar cannot overwrite toString in dollar. Overwritten method is final. Here is telling you that you cannot write your toString because the class dollar already performs a final condition which will prevent you to override it. This is for security purposes sometimes, and also to keep control of what methods or what accessors or whatnot can be overwritten. This is important because You might want to create a different method in order to get away with this. But in reality, that doesn't really give you the flavor that we want. Suppose that we create toString2. Well, that will compile the program without any problem. The only situation is when we compile the Department of Treasury and we run it, guess what output we're going to get? The same toString. This will keep uniformity in the entire toString objects. But usually we leave everything that will be without final just to provide that flexibility. This way you don't have to come up with funky names and keep consistent with all the objects that belongs to Java. Let's save, compile, and run this program. There's variations of these objects. One of the concerns is what happened to keep track of the values, Professor? Keep track of how many instances we create. And there's a way to keep that counter. For that, you might require to create the following. Static class members are rare. We usually try to avoid them in object orientation programming, but sometimes once in a while, we would like to create some kind of static class members to keep track of things or to keep methods or fields accessible to everyone. They should start with public, of course, because we want to access them any scope, anywhere. The word static allows it to be visible everywhere. And of course, data type and the name. In this case, we're going to have a counter. Every time we create a dollar, the counter will be one more. Since the objective of the constructors is to initialize all the fields, we should do that in all the constructors. Not only that, we can demonstrate here a way to extract the total number of dollars used. We can use this by creating $.counter, and this will extract that counter that is being used. But Professor, do we need to do the same thing for Canadian dollar? They are the same. Remember that we have counter as our superclass field, and we should be able to extract and count every time you create a new instance. Every time you see this word new followed by a dollar, you can actually extract that value. Let's save, compile, and run this program, and we're expecting 5 total dollars there, which indeed we got. This helps us to keep track of instances. And as I mentioned previously, every time you see the word new, that means that requires a new instance of an object.